Discrete Fourier series is a frequency analysis tool for periodic infinite duration discrete time signals, which is practical because it is discrete in frequency. So we will use discrete Fourier series for the periodic time signal. There are two equations that we must remember. First, Fourier series representation, x of n bar, from which is n from 0 to n minus 1, and the second one is Fourier series coefficient, which is ck. The k is from 0 until n minus 1. X of n bar is for periodic function. For DFS example, determine the Fourier series representation of the discrete time signal x of n equal to 4 cos pi n over 2, and the period is equal to 4. The first step, we must find fundamental frequency, which is omega naught equal to 2 pi over n, and we will get pi over 2. For the second step is, we should find the Fourier series coefficient, which is ck. To simplify the equation, we will use Euler formula, which is in this step. And then we will get the last answer, ck is equal to 1 minus in the bracket of cos pi k minus j sin pi k. Last step, we sum up the value of ck to form the Fourier series representation, which is x of n bar. Then we will get the answer, x of n bar equal to 2 exponential j omega naught n plus 3 exponential j t omega naught n, which is omega naught equal to pi over 2.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I will explain to you about the discrete Fourier transform or DFT. So the definition is, DFT is the equivalent of the continuous Fourier transform for signal known only at n instance separated by sample times t. As we can see in the graph here, this is the signal. So the signal is continuous, but it is separated by the instant time, which is 1, 2, and until n. So next is the equation for the frequency domain is xk equal to summation of xn ej 2 pi nk over n, and the range is 0, k and n minus 1. For the time domain, xn equal to 1 over n summation of xk e negative j 2 pi nk over n, and both are discrete and finite. So let's proceed to the example on DFT. The question given is, the signal is 1 over 4 for the range from 0 to 2, and we need to find the xk. So here is the solution. Firstly, we have to write out the equation for xk, which is summation of xn e minus j 2 pi nk over n, and then we need to know what are the n, what the value of n. So n is 3, given the range is 0 to 0, 1, 2, which are 3, and then we substitute the value of n to the formula. So xn e minus j 2 pi nk over 3. So we simplify all it, and then we get this equation. So we need to substitute the value of k, which is 0, 1 and 2, into the equation, because the range given is 0, 1 and 2. So the first one is k equal to 0. So we substitute the 0, and then we'll get 3 over 4. And next one is the k equal to 1. We substitute the 1, and then we substitute. Then we can see this is, we need to use Euler's formula, which is this, cos 2 pi over 3 minus j sin 2 pi over 3. And then we simplify, and then we calculate by the calculator. And this we can cancel out, this 2, and then we get simplify this as 0. And last one is k equal to 2. This is the same step, and then we will get 0, 2. So that's all for me. Thank you.
Let's proceed to the discrete time Fourier transform. Discrete time Fourier transform can be defined as x in the bracket of e j omega equal to summation of from negative infinity to infinity x of n times with exponent to the power of negative j omega n. For its inverse, x of n is equal to 1 over 2 pi integration from 0 to 2 pi x in the bracket of e to the power of j omega times with e to the power of j omega n with respect to the omega. For a better understanding for this formula, let's take a look at the example. The example given, x of n is equal to delta in the bracket of n minus 1 plus delta n plus 1. From the previous equation, it can be represented in the graph shown. The graph shows in the x line, 1 and negative 1 is plotted on the y-axis of 1. So a straight line above 1 and negative 1. Now, let's solve this question. To solve this question, we can take the previous equation, which is the equation of e in the bracket of e to the power of j omega. So, from this question, Sn is equal to 1. And the n, there is two interval from the graph, which is negative 1 and 1. So, we just have to put the negative 1 and 1 into the equation, and you will get e to the power of j omega plus e to the power of negative j omega. If you take a look at the trigonometric identities, this formula can be converted to 2 cos omega, and the 2 cos omega is the answer for this question. The graph shown is the constant graph, which is the answer from the previous equation with the amplitude of 2. For its inverse, we can use the same answer to convert it to the previous equation, which is the 2 cos omega. When the 2 cos omega put into the Sn, it will become 1 over 2 pi integration from 0 to 2 pi 2 cos omega times with e to the power of j omega n with respect to the d omega. By referring to trigonometric identities, e to the power of j omega n can be converted into cos n omega plus j sin n omega. After you convert it, the equation will become 2 cos omega times cos n omega plus 2j cos omega sin n omega with respect to the omega. Again, referring to the trigonometry identities, 2 cos omega cos n omega can be converted into 1 over 2 cos in the bracket of n plus 1 omega plus 1 over 2 cos in the bracket of n minus 1 omega. For the second one, which is the 2j cos omega sin n omega, can be converted into 1 over 2 sin in the bracket of n plus 1 omega minus 1 over 2 sin in the bracket of n minus 1 omega. By solving the integration from the previous equation, you will get 1 over 2 pi times 2 times 1 over 2 times 2 pi, and you will get 1. 1 is actually the answer from the previous x of n. Regardless of what you do, you still get x of n is equal to 1. That is all from us. Thank you for watching this low budget video. I hope you enjoy it. Thank you.